Hello, my name is Taylor Ross. I'm the owner of Frustum Virtual in Los Angeles, California. In this tutorial, I'll show you how to create a vertical environment for your tracking area using the Antilatency Pillars and Antilatency Service. So the first thing we need to do is open Antilatency Service. Go ahead and open that. Make sure that you have the Environments tab selected in the upper left-hand corner. I'm going to create a new pillar environment, so I'll select this plus sign in the bottom right-hand corner, and then I'll select New Environment. We need to give this a name. I will call this Pillar 01. For the type, I'm going to drop this down and select Pillars. Then I'll select Next. Since these are the anti-latency pillars, I won't change any of these values. I'll just select Finish. To navigate in the editor view, we can zoom in and out using our middle mouse scroll wheel. We can click and hold the middle mouse button to move around in our environment. Right-click and hold to change the tilt of the environment. This will allow you to see the environment from more of a 3D view. You can double-click the right mouse button to return to the default view. Use the left-click mouse button to select pillars. You can also left-click and drag to select multiple pillars in the environment. By default, there will be 2 pillars that are already placed for you. These 2 pillars will represent the 0 point of our camera tracking volume. These pillars are also synchronized, so any adjustments made to either pillar will be mirrored in the other pillar's location. These 2 pillars are different from the rest of the pillars that can be added by the user. They can only be moved in synchronization on the X and Y axis. This is to maintain the environment's center during editing and optimization. When placing your first 2 pillars in your physical environment, you'll want to make sure that they're on the same axis, because these first 2 pillars will be representing our 0 point of our tracking volume. The Anti-Latency Pillar Tracking Volume Kit comes with 4 pillars, so I will start by adding 2 more pillars to my environment. On the left-hand side, I will select this plus sign to add additional pillars. Now I will left-click in my environment to add pillars. I'm just going to place these pillars in the general area that they're placed in my physical environment. Now I'll select the plus sign on the left-hand side to stop adding pillars. For a 4-pillar setup, the best shape to create is a trapezoid. So in my environment, you can see that these furthest 2 pillars are a little bit closer together than the first 2 pillars that were placed. Now that all 4 pillars have been placed in the environment, I need to assign the pillar type. I can left-click to select my pillar. Now in the details on the right-hand side, you can see that there are 3 different types of pillars. We have a red, a green, and a purple. The differences between these pillars is the placement of the center IR marker. We will need to tell anti-latency what pillar is in what location. I know that my front left pillar is purple, so I'll go ahead and select that. This back left pillar is green. This pillar is red, so I'll leave that alone. And then my front right pillar is also green. So again, you'll just have to look at your physical pillar, and based on the position of the center IR marker, you will just select the corresponding color. Each pillar in the Anti-Latency Pillar Kit also comes with a platform. There is a cross in the center of this platform that will be used for taking measurements between each pillar. There's adhesive tape on the back of each platform that will allow you to place it on the ground securely. Once the platforms are placed, you will be able to easily place your pillars back in the correct position once the measurements are taken. So we've started by placing our pillars in a trapezoid configuration. Now we will place the platform and secure it to the floor. Once all of our platforms are in place, we can take a measurement between each platform. Once we have all our measurements, we can place our pillar back in the correct position. Here's a diagram that shows where you will be measuring from on each platform. In order to make sure you're getting the most reliable measurement, you should use a tape measure. And remember that all of these values will be in meters. Back in Anti-Latency Service, we have the ability to change the direction and viewing angle of our IR markers. To change the viewing zone, select the pillar that you'd like to change. Then while holding down Control, you can scroll your mouse wheel. By default, the viewing zone is 360 degrees. The viewing zone will be reflected by this green circle. To set the viewing direction of the reference bar, hold down the Control button, left-click on the selected reference bar, and then drag in the desired direction. For this tutorial, I will be leaving the direction and viewing angle of the IR markers at 360 degrees, which is the default. But if for any reason you need to change this, that's how you do it. I will now start inputting all of the measurements that we've already taken. Since the first 2 pillars are synchronized to represent the center point of our tracking volume, I will take a measurement of the total distance between these 2 pillars and divide it by 2. This will effectively give me the offset from our 0 point to 1 pillar. I'll just quickly open my calculator to show you this. The total distance between both of these pillars is 3.259 meters, so I'll divide this by 2. Now I'll go ahead and copy this and place it into the X value of my front right pillar. This will offset both of my pillars equally from the 0 point. One will move in a positive direction. If I select this purple pillar, you will see that it moves in a negative direction. So anything to the right of our 0 point will be positive and to the left will be negative. Just remember that all of the values that you will enter will be from 0 The rest of these values are a little bit harder to input in this way. So rather than trying to find that offset from 0, I will be adding constraints and then using the optimize function. I will start by holding Shift on my keyboard and selecting the first 2 pillars. Now on the right side, I will select Add Constraint. The constraint is the total distance between both of these pillars. Anti-latency is auto-calculating this for me, and you can see that it's 3.259 meters, which is correct. I will now select OK. Now in our environment, you can see this constraint represented by this green line. If the difference between the distances is within an acceptable limit, then the line and the number will be green. If the distance in the environment is less than the measured distance, then the line and number will be red. If the distance between the markers is greater than the measured one, then the color will be blue. Now I will go through and input all of the constraints for all of my pillars based on the measurements that I've taken. I can select multiple pillars by holding Shift on my keyboard. I can then left click to select the next pillar, select Add Constraint. The distance between these pillars is 1.542 meters. Press Enter or select OK. You can see that the line between these 2 pillars is red. As I mentioned before, this is because the distance in the environment is less than the measured distance. So these 2 pillars are actually much further apart. I can move this red pillar to show you where it should be. Once the pillar is in an acceptable range, the line will turn green. You don't really need to worry about this because once we press the Optimize button, all of our pillars will be repositioned into the proper positions to match our physical environment. As long as the measurements that you've taken between each platform are correct, all of your pillars will be repositioned to their proper position to match the physical environment. I'm just going to Control Z on this movement. Now I will continue inputting all of the constraints for the rest of the pillars. Hold Shift on my keyboard and select the 2 pillars that I'd like to add a constraint to. Select Add Constraint on the right-hand side. The distance between these 2 pillars is 2.746 meters. Again, we get a red line. I'm just going to move on to my next constraint. Hold Shift, select the 2 pillars. Select Add Constraint. The distance here is 1.547 meters. Now I'm going to add my diagonal measurements. So from corner to corner, Add Constraint. The distance between these pillars is 3.336 meters. Select OK. And now for my final corner to corner measurement, Add Constraint. The distance here is 3.398 meters. Go ahead and select OK. So looking at this, all of these red lines are telling me that the pillars in my physical environment are much further apart than the pillars in Antilatency Service. On the right-hand side, I will now select Optimize. All of my pillars have now been repositioned to match between Antilatency Service and my physical environment. So as long as you're confident in the measurements that you've taken in your physical environment, you should now have a really close representation in Antilatency Service. Now for the final step in this process, we're going to visually calibrate. To do this, we need to have an alt connected to our computer. In the upper right-hand corner, I'm going to navigate to this Calibrate tab and select it. So now that we're in our Calibration tab, it's recommended that we do this in 2 passes. For the first pass, we're going to get a frame count of around 500 to 1,000 frames, and then we will do a second pass where we gather 5,000 to 7,000 frames. The maximum frame count shouldn't exceed 10 to 12,000 frames because it will introduce too many errors. Just remember that the optimal frame count is 5 to 7,000. So now I will start the first phase of this calibration. I'll just select Begin Collecting. Just remember that we want the alt to see all 4 pillars. So we will just walk the alt around until we reach 500 to 1,000 frames in our frame count. Once I reach 1,000 frames, I'm going to hit Stop Collecting. Then I'm going to hit Calibrate at the bottom. Once I select Calibrate, you will see that my environment updates. Now I can select Clear Dataset. This will clear the dataset that we just gathered with those 1,000 frames. And now back at the top, I'll select Begin Collecting again. For this tutorial, I'm going to fast forward through this section. Just remember that the optimal frame count for this pass should be 5 to 7,000 frames. Once I reach 7,000 frames, I will select Stop Collecting in the upper right-hand corner. I will then select Calibrate at the bottom. Now in the upper left-hand corner, I will select this back arrow, and then I will select Apply. This will apply the calibration to my environment. Back in the main editor view, you will see that I still have some blue and red lines between some of my pillars. The color of the line indicates the difference between the distance set in the constraint and the distance after calibration. There's nothing that we need to do about this. Anti-latency service is simply showing us the discrepancy between our calibrated value and the constraint value that we entered. If you click Optimize after calibration, the pillars will adjust to the constraint data you initially entered, and the calibration result will reset. To finalize my calibration, in the upper right-hand corner, I will select Save, and then I will select the back arrow in the upper left-hand corner. The last thing we need to do is make sure that this environment is set as our default environment. Select the 3 dots under this new custom environment, and then select Set as Default. This will be reflected by the blue check mark in the upper right-hand corner. We can now close Anti-Latency Service. Your pillar environment is now ready for use. Hopefully this video was helpful in showing you how to create a vertical environment for your tracking area using the Anti-Latency Pillars and Anti-Latency Service. Be sure to like and subscribe for more videos, and thanks for watching.